Yeah, thank you for everyone who's here. And also thank you for watching if you see this recording after we're done. My name is Jan-Paul Dubbelman. Today we're going to talk about the SOP solver in Houdini, which is a little bit tricky solver to work with, but we will go over through two different setups that will make sure that you will understand both ways to approach the SOP solver, and I think you will see that it's very powerful. We will be working with more of a little bit more philosophical than last time. We will be using certain concepts that make a lot of sense for me while I'm working. And so I would like to also, if anyone here has a question about how I get to a certain decision, please do that, because everyone works in a different way. And I would like to show you how I approach the work. We will mostly go over building these different systems that create life. And then at the end, we will be rendering a little bit as well. So we can talk about how I approach lighting and certain tricks that make your lighting feel more realistic and also a little bit more thought out and art directed. So this is what we will be doing. Today, we will be talking about the SOP solver, which is basically doing something over and over again while slowly changing some parameters. It's a very interesting way of working where instead of really thinking about every step in advance and then making decisions, you basically guide a system towards a certain end result. So first, let me introduce myself properly. My name is Jan-Paul Dubbelman. I am a digital artist from the Netherlands. I've been using Houdini for about 3.5 years, I think, and I'm mostly interested in very calm, relaxing, and lifelike simulations that I then render in a very warm and approachable style. If you follow me on Instagram, you will see a lot of this type of work. This is all experimentation and a lot of unplanned designs that all stem from my way of working, which is using Houdini to guide the process of creating these kind of shapes and movements. And I like flowers a lot, and I like nature, and I like things to be very calm. And the SOP solver is one of the ways that I use, one of the ways that I get to that lifelike, calm nature. So in almost all of my work, there's a SOP solver involved, and we will be going over certain tricks to get there. And I also have exhibitions sometimes, and the reason why I think that people gravitate towards my work is it's very natural, and I like to make stuff that creates a certain atmosphere in the room. And again, coming back to that naturalistic design, that's a very easy way to get to this feeling of life and feeling of warmth. And so maybe it's an interesting tangent to just talk about how a lot of digital artists and 3D designers show themselves on social media. Just for 1 second, talk about that. What happens a lot is that once we create our work, we post it on Instagram, and we know how much time and effort is put in there, and we know how it might look on your phone or on a display. But I really encourage people to either create their own little exhibitions or try to work together with other people, because once you see your work in these big rooms, it completely changes the atmosphere of the type of work that you're doing. And sharing that with other people really puts your work in context, and it'll create a sort of personal brand that people can relate to a lot better than just seeing your finished work. Because what I find on Instagram is that when I post my work just like that, I might get a lot of good responses from other artists, which is great. But my clients usually want to see it in more of a context. So I'm very actively trying to get my work on screens, and I can recommend everyone do that as well. Why I like to use Houdini and why I chose to learn that software and why I'm very happy that I did is because in Houdini, your approach to work is very different than when you work in ZBrush, for instance, and most of Cinema 4D or After Effects. It has this feeling of creating something new and then finishing that product, and then that's finished. That finished video or installation or whatever you're creating is then finished, and then the next project you have to start over. So in our minds, we might think, okay, I can copy paste certain tricks that I did last time, but in reality, most of the time you're starting over. But in Houdini, it's a different approach where you create these systems that help you get to a certain design. And what I was saying before the class started is that these days my clients don't come to me they don't really ask for a storyboard or a script. We're mostly looking for getting to a certain vibe. And that's why I use Houdini to get to this feeling that we're looking for. And the SOP Solver is very powerful to do that. I like to think about the SOP Solver as some very sensitive and fragile way of creating your work. It's a little bit fragile. So if you certain settings that might intuitively reach a certain design, you might have to tone them down a lot. But we'll get through that in this class. When you start your project, the only thing we did is create a sphere. What usually people use the SOP Solver for is to either spread or grow. Either you spread your attributes or you grow your structures. And so we will be doing both, because both of them require a slightly different approach. And I think by the end, you will understand why the SOP Solver is so powerful. When I see people use the SOP Solver, there's a lot of tutorials about how to create coral or growth. Right, this wetness map is also a good idea. You can also do that. Let's just dive into the SOP Solver. So a few kind of gotchas while using it. First of all, it's called Solver, not SOP Solver. Okay, so we just put that in the first input. And what happens if you jump into the SOP Solver is that you will see a whole new network. But basically, for the first setup, we're only going to be focused on these two, which is the previous frame. So whatever the previous frame pushes in, we will get through that in a bit. And then the output. So in here, we will be creating steps or some operations that will be repeated in the next frame, in the next frame, in the next frame. So you can imagine that you can picture it like this, is that here something comes in and then there's an output and then it goes back, and then it goes back again and again. Every time you go to the next frame. So previous frame goes like this, right? And it goes circles and circles. One way to visualize that is to use a transform, very simple. Put it in here, and you just say 1 or 0.1. And now every time you go to the next one, it should move, but it doesn't. And the reason for that is that we are inside the SOP Solver and we're also focused on what is happening over here. So once you're inside, you won't be able to see the result of the SOP Solver, which is something I think Houdini should be a bit more clear about. But what you have to do is to go back up, highlight this, make sure that you're outside of the SOP Solver and press this little pin here to focus on this context, right? The geometry context. Because once you're inside, whatever you're doing in here will be propagated into the next frame. So here what I did is just scaled it up just a little bit. And this is why I said it was fragile, because even just a 5% increase goes really fast. But you can see that every frame now, so it scales it up a little bit, and then it goes back, and then it goes back, and then it goes back. And so when you play that, you will see that it keeps growing. That's how the SOP Solver works. You're basically repeating a step again and again. But what you can do with that, you can actually see it here, like it's growing, okay? So this is why it's so powerful, because you can create systems that can grow. So what we're going to do now is to create a piece that will eventually look like coral. But what we want to do is to create a system that grows an interesting shape and use a lot of art direction steps in between to get to a shape that we like a lot. So I think everyone knows the soft peak node, because what this does is that it moves your points based on their normals. So you increase the distance and it blows up. So right now it's doing every point, but what we will be using is this attribute function. Right now there's no attribute yet. So let's create an attribute adjust float. And we will create life. So I like to call this attribute life because it will give you this feeling that we're creating a kind of a force of life into the system. Okay, let's visualize that. So I just press this button here, and now we are visualizing that attribute, which will be very important throughout this system. We want to know what is happening in that system. And then we will use instead of the constant pattern, we will use a noise. Okay, so we have an interesting noise. And then let's use this soft peak and use in the distance attribute, use life. So now if you press play, probably should mess that up. Okay, something is happening. Not exactly what we're looking for, but you can see that it's every frame is growing, pushing itself away. Okay, so we're getting somewhere. A little bit less even. So that's why again, like it's a very sensitive system. Like a distance of 0.001 doesn't sound like a lot, but if you combine that with every frame, you'll see it's still growing quite quickly. So it's taking this attribute here and pushing itself away. Okay, this is not exactly what we're looking for, because what we have now is that the noise is basically too soft. Right now, there's too many spaces that are being pushed out. So what you can do here before it goes into the soft peak, and make it small. I think a shape like this is usually quite nice. So you have this kind of ridge here, the ridge of high density. So now if you, everything that is red here, it'll push it out, right? You can see that the redness is being pushed out. So it's going in here, getting an attribute and then pushing itself apart. And then here it goes into this out and then it goes again and again. But what it's doing in the beginning is that it's adding life every frame. But even though we say here from 0 to 1, every new frame, it gets more life. And this is represented by this red part. You can see like in the beginning, there's a pretty soft noise, but then after a while, it just gets overwhelmed and now there's too much life. So what we'll do is that instead of saying add, we will say set always. So every frame, it'll get the same value over time. It will get the same value. It doesn't go over the one. If you press play now, see it? That should grow. Nice. Interesting. Maybe a bit faster. Okay, so this is what most people use the SOP Solver for in the beginning, to create coral, because coral is a very interesting shape where it gets nutrition from the sea that falls down on it, and then where the nutrition falls, it can grow towards, or maybe it's growing towards the light. So what we're going to do in this workshop is to simulate all of those natural systems. But you can see that we start with just move up once. We just start with a sphere. Doesn't have some points, but eventually what happens is that once you push it open, you get these jagged parts because there's not enough points to hold out the detail. And your first impression might be, let's create more frequencies, right? More points. Now it's pretty dense. But eventually you're going to run into this problem because it's going to run out of detail. And you would have to give this like millions of points to keep this detail going. So instead of that, what we will do is that we will remesh the object every time so that it can keep up with the shape. So there's this remesh node. We'll put it in between these two. That what it did is that it tries to recreate the shape with as few points as it needs based on the size here. So right now the target size is 0.2. So if you decrease that, you will see there are more points. So for this workshop, as the value of 0.05 is usually pretty good. I think if you finally cache this out, you might go a little bit smaller, but what you will see is that a value comes in from the previous frame. So it's the first frame here and goes into this life attribute. It gets a noise applied to it, then it gets remeshed, and then it gets pushed out. And the attributes actually transfer between these two, which is very nice. And what you see now is that it starts to recreate itself every frame. And I think that you've probably seen these types of growths already, where yeah, it already looks like coral, right? There's this natural, again, a natural vibe to it. If you turn off the here, if you maybe you have to scroll down a little bit, but there's this icon here, which is the visualization tab. If you turn that off, it's already quite an interesting shape. And of course, if you could even maybe animate this, go to animation. That's why we created this live attribute. So you can see that wherever it's not blue, so blue is basically white. Maybe let's change the visualization here. So you have to, maybe let me do it a little bit slower. So right click on this icon, and then you will see your attribute that is visualized. And let's just make it black and white, grayscale. So you see that everywhere where it's white, it'll try to push away. And everywhere that's black, it doesn't. And we can control that with this noise here. So if we change this noise, maybe create a different noise. Maybe this one. So now we have this sort of a cell pattern going on. Can change the size. If the remesh does its job well, it'll remesh itself without too many holes. So we won't be going over that part of the de-intersection itself, but you will see that the kind of shapes we're working with today, we won't actually need to de-intersect that much. It should actually not de-intersect, but it might a little bit in the end, but it won't really matter for the shape that we're going for. But again, so if you press play now, you can see the white parts are pushing out and the black parts are not. And so this is how you can create that shape. And if you animate this, it'll also work, because every frame it'll get a new, slightly changed value. And let's turn this off. You can see it's actually quite an interesting shape. So we have created life. It is growing. And this is quite nice. This is an interesting shape, maybe. You can see here that when it wants to start to intersect, it fixes itself. And I don't know if you can see that. It tries to not intersect, and usually does a pretty good job with that. So this is the basis of almost every coral growth. You create some shapes that you want to push out and just let it go over time, and it'll create an interesting shape. But the SOP Solver, you can do a lot more things to guide a walnut. Yeah, you can create a brain with this as well. So, or you could maybe add some more areas in the noise that don't go as fast. I like to, maybe it's just me, but it always makes it feel like it's massaging the shape, where it's great, like it's not there every frame, it's fluctuating and going. Yeah, so this is already a pretty cool way to create your system, but I will give you some tips to guide the process a little bit more. Actually, let me go back one step, because I would like to see both the visualization and the final shape together. So to do that, just create a transform under your solver and see, push it apart a bit, and then use a merge those two together. So now we have two, and be a little bit more distant, and then turn off the visualization. So now they're both white, and use a color node to visualize that transition, that live attribute. So color node, color type is ramp from attributes. Just put live here, and you will get that back. You can see that this is a good way to visualize how your growth is forming. Right, so it'll make a little bit more sense why it's moving and what the final shape looks like. So what we're looking for are shapes that are, so what we're basically using are three things. We're using this live attribute here, but in the soft peak, what we're using are the normals. You can visualize your normals by this button here. So it might be interesting to point the normals up. So what is happening now is that if you just play, you will see that it's uniformly growing, right? So it's an interesting ball, and it just keeps growing and growing. But in real life, the shapes are always growing towards something, towards a light, which comes from above. So to simulate that, it might be a good idea to use these normals to guide the shape into the right direction. And the one cute way of doing that, before we go there, let me just turn off the animation. Because if that's turned off, I think it's a bit more predictable where the shapes are going. Already looks quite cute. What we'll do is we will create a velocity vector, which sounds weird, but I think that this is, for me, the best way to visualize where the normals are pointing. So the node that we use for that is the point velocity node. So if you put that after the remesh and you press this button here and add velocity, these little blue lines, little greenish blue lines, start to point down, which means that there's a speed in the shape now that is pushing itself up. So down actually means that it's being pushed up, right? So this is more the speed trails. But actually we don't care about this velocity, but we want to control the direction of this soft peak here because it uses the normals. We want to art direct that direction. And I'm so sorry, but we have to use Vex for that to keep it simple. So we'll use an attribute wrangle that is very simple, I promise. So in this attribute wrangle, what we want to do is to turn those velocity vector, which is the same type as a normal, right? The vector into the normal direction. So what we'll do is v.n. So vector n attribute is the same as the vector n plus the vector v, which is v is the name for velocity. Maybe you could see it, but so what is happening now is that if I turn off this velocity and visualize the normals, doesn't look like much, but if I turn this up, see? This pushing itself up a little bit. And so it's going to do this every frame. So let's run this and see what happens. You see it right now, it's being pushed up. Every frame it's gives a little bit more life to the top parts and a little bit less life to everything down there. And now we're getting into this really interesting coral shape. This actually looks quite like coral already. And this velocity, you can also do other things with it because it has this curl noise. So you can add a little bit of curl noise if you visualize that. You turn it on. You can see that just a little bit here. Points go to a different direction. And how I won't make it animated because it'll maybe freak out a little bit. Even just adding a little bit of that curl noise will make them a little bit more going back and forth. You can see them trying to fight against, it looks to me like it's fighting against a noise that is in there. And again, you create a little bit more lifelike detail. And what's really nice is that if you see this growth pattern here, this smoothing going on. But this is the way to use a SOP solver to only consider its own inputs, basically. In the next setup, we will create a different type of system, but here is a way to create very naturalistic shapes that are just a couple of nodes long. Yeah, so for me, a very sort of philosophical way of working almost, where you create these systems of where life starts and then it keeps growing, it keeps going by itself. Every time that it hits this life attribute, it sets a new value from 0 to 1. So right now, this one is only, it's not adding or removing, it's just setting the value every time. And because the noise doesn't move, there's this noise in the air, let's say, that it gets applied every time. But I think what you would like to do is to stop the growth at some point. Because right now, if you press play and you let it go, it'll just keep growing forever and ever, and you're basically never finished. But what you can do is to slowly take value out of the system. And one way, we will be going over that a lot in the next class, but just for this example, this is my favorite expression, the fit attribute. So you want to fit the $F, right? So the frame number, and let's make it start to lose its power, let's say at around frame 120. So what you want to do is to set a range, 120 until maybe 200. And then the max value should be going from 1, which is setting that value every time, to 0. And what you'll see now is that, so it's going here, it's still gray, white-ish. Then when it starts to hit in 120, maybe I should have done a little bit earlier. This really depends on how fast your computer is. But from 120, you should be seeing that this grayness disappears. And it very naturally loses its energy. And eventually, when it gets to 200, very sad moment where we see all the light leave the system. But eventually, you will see that all the light goes away. And what you'll end up with is a finished structure. So now if you play this back, you'll see that it's a lot of life in the beginning, but then slowly it'll stop. And then you'll have a sort of finished piece. And this is, I think, what I use this for the most is to create an interesting base for the other objects that I'm using. Very rarely this is the main shape in my compositions, but it's an interesting base because it has a lot of like nooks and crannies that are interesting to put flowers or grass or whatever you want in there. So some limitations are that if you see these point numbers here, this might be a little bit too small, but if you press this, you can see the point numbers. You will see that every frame, the point numbers, I don't think you can see this, but every frame, it's recreating a new shape, right? So every frame, it creates a new point number, which won't allow you to do a lot of different things, like attribute copies will be very difficult. You can do an attribute transfer, which usually works, but copying won't work. Vellum also expects a consistent shape, which won't work. And things like UVs, I don't think there's UVs on here now, but let's just put them there and you'll see what happens. Sphere, so polar, this. Okay, so now we have a sphere. It's already messing up, but see if you press play, it's maybe interpolates the UVs, but you will also get a lot of stretching going on. So you could use the SOP Solver. If you remove this remesh here and then let it go, everything will stay consistent, but you will get a lot of other problems going on, right? So you would have to do a lot of transferring and then cleaning the UV. And there are some techniques to do that. You can use some REST attributes, but I won't be going over that during this tutorial. But yeah, basically there are some limitations when you use this. In the next setup, it'll get a little bit more consistent. You could use those for Vellum a little bit better. But what you could always, of course, let me turn this off. You can always, of course, just take the last frame and use that as your Vellum input. That will work, but you won't be able to add more. You won't be able to let it grow while it's being when it's part of Vellum. Okay, so we have our nice shape, but I think we can get even nicer. So one of my favorite nodes is the labs. I hope everyone installed labs. It's just, you should have this in your file once you're installed. When you install Houdini, it asks install labs, and I hope you said yes, because they have a lot of tools in there that are very easy to use, and there's some in there that are very powerful. And my favorite is the labs sharpen mesh sharpen. So because what this does is that it sharpens the mesh up. And what's nice about the SOP Solver is that it's going to do it again and again and again while it's growing. So if you put that in here, this is what you get. Press play and it goes away. So basically, it's just much too powerful. So if you make the step size 0.001 and then press play, the shapes here now have a much more angular shape to it. And I think a much more realistic kind of maybe stone shape. And so that's why I said that vellum is very sensitive. You have to make sure that it only affects certain parts, because you can see that eventually it doesn't have enough detail and it just shrinks into a duck this time. But so you can see that even with a very tiny step size, it's still too strong. It's a very sensitive system, but at the same time, everything you put in there, it'll very subtly, but it will definitely have a big effect on the final shape. So these right now, they seem a little bit more sharp and a little bit more considered, almost a little bit more hard surface model-y than what we had before. Right, so again, I really like to look at these. You can see the life flow through the system. If you use the remesh, you make the shape a little bit smaller, you will get a better result. But here you can get a pretty good idea about what you can use Solver for. And just sharpening it up a little bit, or maybe here you can, at the soft peak here, you can maybe increase the steps a bit more. Now it just goes twice as fast. You can get a completely new shape that's very different from what we had before. You can see that what I also really like is that it finds these areas to grow, where in the beginning, like somehow this shape here is the largest, but then later on, the one on the left catches up to the first one. And this is just this very kind of natural way of growing your own models. If you want to sculpt this, you would have to get reference and then sculpt and then, right? But I like to use Houdini much more as a assistant to get to the shapes that I'm looking for. Yeah, so for instance, if we make this live, if you make this a lot bigger, now we get this big exploding feeling again, where you have a lot of different tendrils. But then if you make this sharpen a bit more, even a bit more, already getting a little bit more sharp shapes, maybe even more. It's almost like a rock. Very, yeah, so again, a very sensitive system, but you can get to very interesting shapes. This really has these facets. This kind of rocky. Maybe I really like to put a lot of contrast here. And then, especially if you make rings like this, rings do really well. So you see like it has this kind of hard edge. So yeah, maybe the sharpness too big now. Yeah. And too strong. Again, very sensitive. Here, yeah, you get like a very kind of sharp flakes almost. Very thin shapes, but it's still going. It's still trying to build itself up. Sometimes you get circular elements. I really like these kind of thin sheets where you have almost like someone sculpted it. You get this like fine line, and that sharpen really adds this detail where it almost feels like a real model. This could be like, I think that this would work really well if it's the shining mirror-like material. That's why I called it live, because I think that's a good philosophy to look at your work like this, is that we're basically giving it a lot of different tools to grow. You can add so many different things. You could, let's see, another one that might be nice is if you do a mask by feature. If you've ever used this node, but it's also very powerful. If you this mask, but if you call this live, you get this little dot up here. And if you make it big. So what it's doing here is that it's basically calculating a light coming from the sky, coming from up here. You can change it. You can change the direction of the light. You can also add ambient occlusion, but we won't be going over that. But now I'm using that instead of this live attribute over here, we're creating this thing come from up top. And if you do that, it'll just only grow up because there's only life, the sun almost, coming from up. I really like this feeling here where you're losing, because some parts are becoming shaded, so it loses its sunlight. Again, very realistic way of working. At least I really like this. It makes me feel like it's like you're creating something alive. Sharpen a bit higher, you can. Oh, no, it's losing. Oh, what you could also do is another little hack. Group expression. Again, little bit of text. I think we will manage. And I'm just going to turn this off to make sure that we can see what's happening. Because so right now we're in the solver, so if you press play, it will only go one step. So basically it doesn't work. So we can make a sharpen group and make it a point group. Okay, so here you can create a little micro expression to choose which parts of the mesh are in a group. And so what we can do is the attribute live is higher than 0.05. Like everything that is lighter than black is now in part of this group. Maybe we can do a bit more. So now everything that is very bright will be part of this group. You can use only this group in the sharpen to force the sharpen not to sharpen up, polish up pieces that are not part of that group. And let's see. Should be fine. Okay, so sometimes you have to reset the simulation in the solver when you add a lot of new attributes, because it reloads everything. And so now, see that the original ball here doesn't get sharpened up, it doesn't get smoothed, let's say, or polished, but everything up here gets sharpened. And again, very interesting, completely new shape. It wasn't there before. And I think it might actually could benefit from a little bit more sharpening. So again, in the group expression, just make it everything that is not completely black should be sharpened. Okay, see, it's creating kind of these main shapes that dominate the rest. Maybe give this more and more sharp. It'll change the structure completely. So this is, again, the only thing we're doing here is starting giving a life here in the beginning, right? So it starts here. And then, so why is creating all of these different tendrils now? It's because we use this point velocity with a curl noise, which adds all of this kind of slight deviation. And eventually they start overlapping each other. You will see that they lose their energy over here. And so eventually all the shapes will be gone. Oh, what did I do? Did I do that wrong? Sharpen group. Yeah. This will probably change it a lot. Yeah. I would say that has an effect now. Okay, so even without the sharpen, it looked nice. But you can see, like, in the specular lighting, these nice ridges that are forming. And again, this is a way to art direct your growth. So just when we turn it off, you will see it has a lot more opportunity to grow. And right now it's just reaching for the sun. There's some hard shapes, there's some less hard shapes. And of course, you can also, when you're finished with all of that, let's just go here. You can just add that sharpen at the end as well. A little bit more. And you'll get a pretty good, I really like this line here. That's what I'm looking for when I create hard shapes. This should be pretty consistent over the shape. So this is a way to grow a structure, and if it should be that if we increase this velocity here, it'll also, you can see it already, it'll change the shape quite dramatically. So every frame, the normal gets a new kind of position, and sometimes it freaks out a little bit, but you can see it like a pretty dynamic way of creating these types of models. I mostly use this to create a base for my model, so then UVs are not as important as if it would be a hero element. You can get away with a lot of procedural systems. I think this is a pretty cool shape over here. Right? We can also use those attributes to render, by the way, which we will do at the end when there's time. Also, so this live attribute that we've made here, it's in there, and you can, again, art direct the colors. So if you change these colors over here, now it is even more like a flame almost, right? Oh, you can just, and so this is for rendering, of course, very powerful. Maybe before, and so you can subdivide it as well. In here, a little bit more detail, and then attribute blur. So also nice is that, and this should work on, if you put this afterwards, the structure has grown, but then using these procedural tools to just add a little bit of more detail at the end, that really means that it's a non-destructive workflow, right? So if you would sculpt this and then you would want to color it, you would have to be pretty sure about the final shape that you're going with. But here you could say, oh, I wonder what it looks like if you add more of an explosion type feeling to the shape. You can control all of that with this point velocity here. I think if we can, yeah, molten stone, also a good idea, a good reference. Here you can see the shape of this curl noise. You make it really high, right? You can see it curls around itself. You can make this swirl size bigger. But there's also the conical noise, which pushes it up even more, right? So this is loud. But you could maybe change the direction here a bit. See? And now it's going up, but it's also getting pushed over a bit. I really like to see it so now you get these flat terraces almost. Might be a bit too much. But yeah, so this is how you can influence a simulation. And of course you could animate all of these velocities, or you can add more noises to get more detail. But I think the key here is that you're working together with the shape to create an interesting result. This is a really nice way to create a system, to create these kind of natural structures. I think very powerful as well. And also actually quite quick, right? So if you would do some of this in Pyro, you could maybe get a similar structure, but you would be waiting a lot longer to get to a result that you are comfortable with. Because Pyro takes a lot of art direction away from you because it wants to be realistic, but this doesn't really have that restriction. Here, what we did is create we started with an attribute. We create an attribute, and then every frame, it just looks at the previous frame to get that attribute. But what we would have to do here to vary this attribute is to change a lot of this. But what you can also do is to use the first input of the solver to add new life. And the way I want to show that is what we will be creating are these synapses. Again, we'll start with something very simple. I'm still focused on that other geo network, so I'll just go out of. So what we will be doing now is to create these veins. And there's some ways of creating veins, but I think the best system is to find shortest path. node, find short path. And what you can do with this one is to say, I want to go from a point somewhere on this surface, this point, and find a path towards other points in the object. So if you have to have at least one group to get this started, so create a group, right? Make sure it's a point group, and we'll call it start. And what we'll do here is we'll just, by random chance, create a couple of points. Hope you can see these points showing up. And this will be our starting group. And then here in the find shortest path, what you have to do is to create a start point. And then you have to also create an end point. But what you can do is an exclamation mark, which means everything except the start group. And you will see it starts to create these little lines. And here, so this creates these connections between points. And right now it's just creating a point connection between its closest point. And we have to change that by going to this output here. And then so from each start to any end, but it just goes once. We can go from any start to each end. You'll see a lot more connections have just appeared. And here, if you go to these path costs, you can give a cost, like how far it can grow. Yeah, these connections start to form. And the fewer points you have here, the farther it'll look towards the other points. You can see that right now we're getting this interesting sort of snowflake shape. So if you create a grid in here, where did my grid go? Again, here in the starting group. At some points, maybe a little bit more. We can get these interesting shapes. Might not be exactly what we're looking for, but here with this cost here, you can create how far it'll look for these shapes, right? That's an interesting way to create these groups, these lines. But what you should keep in mind is that the fewer starting points you have, the farther it will look for before it ends, right? So you can see that the fewer percentage of points I select here, the farther they will go. So what I want to do is to create a group in a different way. Let's call that start by creating a cube and then creating a match lines. And what I will do is that I will put this in here in the first connection and this in the second one, and then here in this justify why it's to put the maximum y to the minimum of the sphere. So what I did is that I put the sphere in the second input, and now it will try to move this box based on its input right into the second slot. And if we put that cube here in that starting group, highlight it, and then stop adding points by this random chance, but going to this bounding regions and then bounding object. Right now we're not selecting anything because it's exactly under it. If you just move it up a little bit, you have to get some points coming in. And the reason why I make this convoluted system and not just selecting them is because we are going to replace this shape with a different shape in a second. And I want this all to work procedurally. Okay, but now if you go on here, you'll see that it starts from the bottom and it'll creep up. And the larger the more space you give it to grow, the more interesting the shape gets in the end. So this is already a cool way to maybe create sort of a leaf pattern but what I'm feeling here is that it's still very geometric, not very natural. There's some interesting structures here, but it seems too clean almost. So what you can do before, let's actually use a remesh again. And we'll see. But if you use this remesh, what happens here is that here we have this starting group. I don't think you can see this, but it has 6 points. But then if you put it in the remesh here, the starting group will disappear. So we have to put this before, right? And then it should still, because it just pushed it up a little bit, should still at least select some points. Just one over here. But if you, maybe let me just really quickly change this point size. Oh yeah, right, skill point micro size. Yeah. All right, so we have so it's selecting 1 point now. Let's make this remesh a little bit smaller. And what you'll see is that right now it's a pretty even shape. But if you turn this off, turn off the smoothing, you'll get a little bit more variation, and all the variation that you put here in the beginning, it'll all propagate towards this path. More smoothing, less smoothing, create a different shape. So these are interesting veins, but what makes these kind of boring is that they're only on the outside of the shape. What you want is to have the veins be inside as well. Called a TET embed, tetrahedron embed. And the way this works is actually, if you select this, it doesn't look like anything happened between the sphere and this TET embed. It's shifted a bit, but what actually happened is that it filled these whole shapes with pyramids or tetrahedrons. So if you use this clip to see inside, you'll see that there's all of these extra blocks inside now. This is original, completely empty. And here, it created these shapes on the inside. And so if we put this remesh in here, and not a clip, although they might be interesting. But once we add this TED embed, so even though you can't see them, there are actually shapes inside. And again, we'll create a start. Now what you get is that you get veins on the inside, because there are shapes on the inside where the paths can go for. Yeah, so we have these branches, right? Might be veins. Okay, and before we go on, let me just make the shape a little bit more interesting, because spheres are nice, but I want you to understand that you can use this on anything. So I'll just create a helix. One thing that is important, by the way, is that the size of the object changes a lot, because here in this TET embed, for instance, it has this max scale and scale here, and also the remesh uses the size. So you have to make sure that the input shapes that you put in your system are not too big or too small, or the whole system won't be doing what you expect. This helix, for instance, if you make it, is actually quite large, right, compared to the sphere here. So keep that in mind. So let's make it a little bit more interesting. Start radius quite small, and then make it increase a little bit more. Let's go to transform this to, actually, why don't we use this match size? Just change, copy paste it over here, and then use this helix. And right now, it'll push it down because it's still set to this justify mode, but I'm just going to say none and none. And then click scale to fit. Oh, actually, maybe it could be in the center. And then scale to fit. So now everything you put into this mesh size, it'll have the same scale as the sphere, which is of course very important if you want to create these systems that rely on the scale of your scene. Okay, so now we have a nice helix over here. And then sweep. Create some geometry. And let's make it a round tube. A little bit smaller. Now we have an interesting shape. But let's make sure it's closed. Second. So if you go to these end cap, we're going to remesh this. So the geometry here is not super important. But let's make it a little bit more round so it has enough shapes. But in the remesh, a little bit messed up Let's give it a little bit more size, and now a little smaller size, and now you'll have a pretty good surface to get started with, a little bit thicker. Okay, and let's also transform it a little bit so it all, I don't know, just look a little bit nicer. Almost like it's laying on the floor. All right, so different shape, add embed, put some shapes inside. In the clip, you'll see that it has these chunks, and create a starting group, but I want to change it up. Oh, with me, of course, this should go into this match size. And now you will see that it creates, it'll start from here. But I just want to change this just a little bit, because I would like it to start the lowest point, which is here. And then now if you create this find shortest path, it'll create this very interesting vein-like system almost. And it's in 3D, so there's shapes inside as well. And you can turn this up, and you will be able to grow these veins. And I think that actually does a really great job already creating an interesting structure. It's almost an Instagram post by itself. Okay, so that's how you create veins. Because there's not so much geometry, you can see that it creates these very kind of angular, hard shapes, because it's just trying to get to the next point. It's not trying to be smooth or interesting. So what we want to do is to smooth this up a little bit. But if you use this find shortest path, you have to do something before you do that. So here, if we go into this information, I don't think you can read this, I'm sorry, but it says 334,844 points. And that's a lot of points. And the reason for that is that what it's doing is that it doesn't care if another vein already touched that point. It just overlaps it. So it goes from every point in the beginning, and it just overlaps each other again and again. You don't see that, but it is actually happening here. So before we smooth it, we have to collapse them into each other before we do any other operations, because right now we have just too many points. Doesn't look like a lot, but there are actually a lot of overlapping points here. So to do that, just add a fuse node in here. If you just press, if you activate it, nothing seemed to have happened, but we went from 300,000 points to only 5,426. So it got rid of all of these overlaps. And this, of course, it makes things very slow, but it also makes the structure less correct. So nothing happened here in the shapes. We just made a fuse, like you cannot see any difference. Just removed all those overlaps. And that's important, because otherwise, eventually your system will be very slow, and also it won't do what you expect. And what we can do now is to smooth this. So what I will do is just to use a resample. Put it in here. And again, already very cool, beautiful shapes which get smoothed. And I'm just going to turn off this maximum segment length for now, and just go down here and treat the polygons as if they're straight edges. Is what it's doing now, because there's these straight edges, so it doesn't do anything. But if you change this into subdivision curves, you'll see that it gets a little bit of interpolation in between those two shapes or there, right? And so if you leave that onto subdivision curves here, so you decrease the length. So see, now you get these veins here that are very thick, and the more points you give here, the smoother the shape will look. And now we get this very realistic vein shape, right? So now we get it. We went from just model in here, create these hard shapes, optimize it a little bit, and then resample them to make them smooth. Yeah, this looks pretty close to what veins look like in your body. And this is what we will be using for the SOP Solver to create a very interesting system. Let's create a SOP Solver. I always put SOP Solver, but you should just like Solver. Okay. All right. So if we go into this solver and we create an attribute, it's called life, and let's visualize that. And we'll add a noise. Worst. Pretty much changing. Okay, yeah. So you see that certain darker parts and there are lighter parts. And so what we did last time is to put like an initial attribute in there and then keep adding that attribute or sort of remapping that attribute every frame. And what I would like to do now is to add more life throughout the animation by varying where the attribute comes from. Sounds a little bit confusing right now, but you'll get it in the end. So last time we just added the attribute here, but this time we will add the attribute earlier. So here, before we go into the solver, let's create a null just for later. Okay. And what I want to do is to create this synapse, right? I hope everyone knows what I mean by that. It's like you create this activity in your brain where you get a thought and then light goes on and flows through the shape. And the way I would like to do that, so again, to create this group. And what I want to do is to just pick random points in the shape. Again, I'm going to call it life. It's a point enable, right? So now we select all of them, excuse me, and you go down to this keep random chance and then way down, 0.05%, just a few dots, and then attribute adjust float, which will be called life as well. And we will just use that in that group. So now you see I have these flakes in here of again, life. So if you increase this, you will see it gets more light. But I only want to have a few of these synapses going off. So what we will be using the SOP Solver for this time is to spread this attributes throughout the system. And you can create this attribute inside, but there are some advantages of doing that before you go into the SOP Solver. So make sure that this is turned on so we see the result of the SOP Solver. Okay, so right now, in here, it just gets the previous frame. So the way to spread things is a little bit complicated, but we'll go through this together, and I think you'll see how easy it is to control eventually, because what you'll need is an attribute fob. We'll call it the spreader. And so we know that in here, the attribute, the live attribute comes in. We'll go inside into the spreader fob. Make sure that we're still watching the result of the solver, otherwise it won't work. And what we want is to use the live attribute, and to do that, you have to create this bind node, which means that you're looking for an attribute, which is called live. And in the end of this, we want to remap whatever we're doing in here to that live attribute again. Then you can use a bind export, right? So bind is in and bind export is out, and put this live in here. All right, so right now, if we put this into this, nothing will happen. Nothing happens in here, right? I hope this makes sense. So this is the original that comes in, and this is the result. So if we use this multiply constant in here, and we will turn this lower, am I being working? Yeah. So right now, it should remove the attribute every frame, right? Because we're multiplying it every frame by half. So it should be taking away the data that we put in the beginning, because every time it's fetching this original attribute, it doesn't allow itself to remove the attribute. So we will have to get the attribute from somewhere else. 1 second. But before we do that, let's spread this around. And to do that, you need a point cloud open node. So these are these bulb nodes that you might not be familiar with, and they might be a little bit unfamiliar, and they're also a little bit complicated. But let's go through it together. What this PC open does is that it looks at all the points that you give it. You have to put it in this file input. So we know that it's the first input here, right? Where we put it in the first input. And so we put that first input into the file node. And then what it's doing is that it's going to look at its neighbors that are close to it, the points that are close to it. And it creates an attribute for that, which we cannot see right now. We can visualize it in a minute. The file goes in the first, which is the input 1 goes into the first. And then the position goes into the position. And right now, it is creating an attribute, but we cannot see it yet. And the way to visualize that is to create another, probably unfamiliar node, which is a PC filter, point cloud filter. And then you can put it in here and make sure that this value is live attribute. Let's just put that into the color diffuse. So make sure that this is activated before you do all of this. Okay. So here so now we're seeing a color coming out. So if you increase the search radius, you should be able to see a little bit more color. And if you increase these points, how many points it uses, that blurs it. With the fewer points, the sharper it is, and the more points you use, the smoother it is. We still have a little bit too many points. I'm just going to change this segment length to be a little bit bigger. So the veins won't look exactly as smooth as before, but you can change that later, but just for demonstration purposes. Yeah, it looks like a painting already. Yeah, we just got started because this live attribute that we can use. So now if you press play, it'll go away. So where did it go? So what it's doing is that every time that we every time we use this PC open, it blurs it again. So it's taking the average between 2 points and blurring it between that. So now we say you have to look around you in this radius, and then you can use this many points to blur yourself. So that's why if you make this fewer, it only has a few points around it can spread, and then it'll still go on the way, but it'll have less opportunity to spread itself. If you move this radius, okay. So right now it's again like it's losing all of its attribute. Like because we're blurring it too much, it doesn't get new energy. It's nice if you want to just blur stuff, but what we want to do is to keep adding life to it. So what we can do is to take this live attribute that we made before and just use an add. Okay, let's just start with the add. And then, so we take this original attribute and we add, oh, not this one, excuse me, add this newer attribute in here. Get the color. Yeah, here we go. So I'm just visualizing this live again. You see that instead of blurring out, because we added to the original, it'll add to it and it'll grow like this. Right? It goes a bit fast, but you can see like it keeps adding more life to the system, which is a nice effect. But the issue here is that we are constantly using the first attribute that came in here and then using the previous frame to interpolate that attribute. But what I would like to do is to remove an attribute once it's not adding anymore. Okay, and this makes sense when I say it in my mind, but now, yeah, so it's growing in place. So we're not able to change the location while we are in here. And so if you would change this here, this constant value, let's make it into a noise. Right, so the first frame goes in and then it's growing. So what you would like to do is to change this here to go to animate over time. It's not animating, it's just growing in place. It doesn't change anything, even though in here, when you press play, you'll see that it's moving. Right? So what we want is to get new information every time, but what we're getting is we're just really doing all the steps every time. So you won't be able to vary that over time. But there is a way to do that, which is to create and to take the input that comes in the beginning and add that in this second one. Again, in this spreader SOP, add this input one. And then here, instead of the first input, we'll take it from the second input. See if this does something. Looks a bit different already. They can see that it's varying itself already. So now it's taking the solver, sorry, it's taking the first input that we put in here and grab that every frame, right? But because we're adding to it, it's still growing. Cool. So what would happen then if we then take away energy again in the system? So do this multiply constant. Because right now it's just growing until it's white, and then it just keeps adding more and more. So it's not very interesting, it just keeps adding, but then eventually it's white and that's it. So what we want to do is to remove a part. So you can see like it just went a little bit dark, and now if you press play, there will be some energy in the beginning, but it won't spread. And the parts that are not light anymore, the attribute actually disappears. Now you get this kind of interesting, almost like a light show when you play this. Maybe, and the more points you give it here, the further it'll go by spreading it. Okay, so we're adding new life to it, and then it gets removed again with this multiply constant at the end. Getting back to it, so what I would just do is to create these minimum triangle scale, make it a little bit larger so that the triangles are never too small. Maybe that was the issue. Otherwise we'll just keep going. Oh, I see it's a lot faster now. Okay, so make sure that these triangles are not too small. I guess I should have done it earlier. It's all about optimizing the system in the beginning. So here you can see that we're getting kind of clouds of this noise into the shape. But right now, because these points in the beginning, they're always on, right? So these are these random points that we had in the beginning. So here we did this live group, which are these random points, but they're not moving. They're just, or you could create these. If you change the seed, then every frame will have a different seed. So let's try that. $F, every frame is a different seed. And let's just make sure that this is a constant. I don't want to have a noise because otherwise it gets more confusing. So now here, if you visualize every frame, right? It's already looks nice, but so every frame has a different location for that attribute. Let's make a little bit fewer. Right? So you get like an energy going. All right. Now, okay, looks like nothing happened, but this is actually because the attribute goes away too fast. Again, very fragile. So make sure that you focus on this group. So turn this to on. See, right now it's like painting into the shape. See that? every time that there's a neuron there, there's like a little bit of life. It stays, doesn't go away. So if we turn this, maybe multiply, again, very fragile, but if only do that a little bit. So we're taking away a little bit of energy. See, we get like a light that turns on and then turns off again. Because every frame we're getting a different neuron that fires. One frame it might have a value of 1, but then the next frame that neuron is gone, that activity is gone. So then the attribute gets smaller again. But this can, so if you turn this up a lot, you get, imagine being in a forest, right? And then that's what I always think about. Like you're standing in a forest and then around you, vines start to glow. Okay, but here we get this feeling of light being created and then disappearing again. That's nice. Okay, let me just change these visualizers just a little bit. Well, to make it more clear for everyone. Oh, am I doing this? Yeah. Okay. Ramp, use the slide. Remove the visualization that I made before. And then, wait. Okay, so create it. So right now, it's using this color to visualize, but because we're losing quite a bit of energy, it almost never hits this 1 value. So let's make it a little bit, and the range a little bit smaller, and now it gets a lot more clear what's going on. So like painting in these colors, and then they slowly fade away again. And so if you take away energy here, take away more, it has to fight against losing its energy, which again has this vibe of life, where it's like this new information here, but then it goes away again. And so if you turn this off a lot, now it's like the light's not surviving anymore. It eventually, so it'll multiply, like it's taking away a percentage every time. Eventually it'll go to 0. It starts to multiply by, if its value is 0, it starts to multiply by 0. So it never goes under 0. It'll always go to, like you said, like the baseline, and which is 0. But this already has this kind of nice organic synapsy feeling. And of course it goes through the whole shape. Again, these random points. And yeah, so now it goes a lot faster, which is great. Yeah, so this is actually quite quick and it has this synapsy feeling. But what I'm missing here is surprise. Every frame here is it's another flash, which this is cool if you're doing this for a rock concert, maybe. Like cool visual, like just put the camera right in there. Nice. Move it away a little bit slowly. Might look cool, but my style is calm. I want it to be very relaxing. And this looks nice. Looks like this neuron activity, like dopamine, right? But what I'm going for, a bit more time for it to spread. So again, going into this group here, just get this color. And up here, right? So every frame, there's this little flash going on. But what I want to do is to not have it every frame, but every maybe 10 frames or every 15 frames. And the way to do that is to go to this group. And now, this is an expression I like to use a lot, but I sometimes forget how it works exactly. But let's do $F and then this percentage. That's what we're doing now. We're going to slow down this rate of it going off. Right now, every first frame, so that's this kind of strange expression. It goes from, so frame 1 is 1, and then the next goes to 0. 1, 0, 1, 0, 1, 0, 1, 0. Modulo, right? That's a scientific term. And it's a great system. So right now, sometimes it's black, sometimes it's white. Okay? So what happens if we give that, right? Give the number a bit more. So 5, maybe. What it's doing now is that actually it's increasing. It goes from 1 to 2 to 3 to 4 to 5 and then to 0 again. modulo of 5. So what we want is to only fire if the modulo is at 0 every 5 frames, right? Okay, and so if this value here is 0, then do 1, and otherwise 0. So now every 5 frames, it hits once. So let's do 15 frames, right? Every 15 frames. And this gets more into this, maybe a heartbeat type feeling. Okay, so let's put that in the solver. Let's see what happens. So it pushes in a lot of data in the beginning, and then it slowly fades out. And this is the energy that I'm looking for. This is the vibe of life. Okay, this is also very important priority. See, and this is, it makes it feel like strong, it makes it feel powerful. And all of this is, again, procedural, and it uses these veins. And now that we have this system, I think maybe even fewer times, maybe every 2 seconds or something. But so right now we get this nice feeling of this kind of almost an explosive light. So, right, it's quite nice. And especially because it loses the energy, which I think is the most powerful part of the solver, is that you can remove something. You cannot just add more movement, but actually take it away. So quite nice. And so let me just, and here, by the way, so 1 is 1%, right? So we're using 1% here. So if you want to have more, just make this more. Now you have a stronger blast, more dopamine. So here you can change the percentage as well. So you can make it also very, like a little bit, 0.2%. So it'll still work. You're just adding less life into the system, which usually actually works a lot better, because it'll drag your eye a different way, right? Very interesting system, very powerful. And because we randomize this global seed, every time it explodes, every time it flashes, there will be a different seed there. So it'll occur in a different place. So now here in this spreader solver, basically the more points you give it, the more opportunity it will have to spread itself. So the more points you use, the more the spreading effect will occur. And the search radius is capping on how far it can go. So if we make this a lot less, it doesn't quite spread as far. This is more like just like a flash. But if you turn this and a way up, a little bit slower, you will see it goes. Oh. See, it spreads a bit further. It does lose its energy quite quickly. Let's make the search radius a lot smaller. A little bit more. Again, this fragility comes in here, because sometimes it cannot go far enough. Take away a little bit less. You can play with these values here to get this atmosphere that you're looking for. If you turn it all the way up, it's a bit slow now. If you turn it all the way up, boom, and a very like strong effect. Okay, so this is all very cool, but what should you do with this? I think that it has a very powerful system. You can basically throw in any geometry that you like, but what can you do with it? Well, it might not be intuitive when you look at it like this, but this is actually what we're doing, is creating a heartbeat. So if we create a sweep nerve, sweep curve, put that on the, again, round tube, 3/25th frame, should be a flash of color. Tube's a little bit too big. And not still. you get like a forest of lights. Like this is almost this, what do you call it? This fiberglass. I think it might be a bit too big. So when it's physical, it gets even, I think, a stronger effect because you will see more of this overlapping occurring. But what you can also do is to use this life attribute to drive the thickness of these veins. Now first, let's make it a little bit more visible what's actually happening. Maybe, right? This is the same as what we did before, but instead of black and white, there's different colors now. This seems like it gets red. You might see why we're going with this. Attribute remap, and then we will use this life attribute here to drive the P scale of the veins. Now what you get then, need to be a little bit. Let's see what's going on. Yeah, why? See, then you can see it's happening. They're very small. Good. Not exactly what we're looking for. That's probably because we need a little bit more points over here. Let's do it again. Now every 25 frames. There's this first flash over here. And then it smooths out. And of course you can remap this over here. This, the size of the veins actually increases based on how much life or blood or whatever you want to call it is in there. But actually you should turn it around. Right, now. Maybe it should always have some size, right? Because the vein should always be there a little bit. See that? See it with the color? Make sure that it changes the size based on where there is this life. Probably go a bit too crazy with it. It all spreads nicely throughout the system. This could be a pretty good vein or heart simulation. You can, maybe we don't want it to lose quite as much of the energy. Change this over here. Maybe we want to give it a bit more space to spread. See? Yeah, the migraines. Yeah, I'm sorry for that. Okay, so eventually, once you add a lot of points, you will get some slowdown. But if you play this back like this, and then just for sake of demonstration, is that if you put this sphere here in the beginning, inside here, right? So now we use the sphere in the beginning, and then where does it get this group? Gets this group right on this side, and then it gets this interesting shape. Fuse it, resample it, and make sure it only uses the first frame. And I'm here in the solver again, put in a different shape, and then something is happening. And we have a new system. So it's very flexible in that way, and very predictable as well, which is what I'm looking for in my work, especially if you go into the trees. So you can experiment with that yourself, but you get this interesting, like natural shape.